components and networks of electrical engineering. Now, now, first of all, we have to discuss how power reaches us. We are generating power at a far distance from where we are actually consuming. Let's consider this power is generated at the thermal power station, nuclear power station, hydro power station, and from there we are transferring this power through these electrical towers where the level of voltage generally is 800 kilovolt, 400 kilovolt, and even sometimes it is 1200 kilovolt. Usually it is found in between these, whereas at different stages we are using transformer, and these transformer are going to step down the level of voltage up to 220 132 kilovolt lines at the substations. At these substations serves as the intermediate purposes where the level of voltage is further stepped down at 33 kilovolt or 66 kilovolt in sometimes. Now, finally, it is supplied to the nearby locality that is known as the electricity board. After this electricity board, the power is transferred to the particular load type of load. Depending upon the size of load, the voltage level either it is 11 kV or it is 33 kV directly. Sometimes it is 66 kV as well. But at the time at the load end, the load is going to operate if it is three phase for 415 volt or 440 volt sometimes, whereas the single phase load either it is operating as 220 volt or 240 volt sometimes. Now, the single phase here means the supply is connected between one phase and neutral, whereas three phase we are having three different conductors as labeled as R, Y, B. Now, consumer may be of small consumer may be of big consumer. The consumer may be of residential consumer, whereas consumer may be of commercial consumer and industrial consumer. Depending upon the size of the demand of the consumers are categorized as domestic consumer, commercial consumer, and industrial consumer. Industrial consumer is usually having a load demand of more than 100 kilowatt, whereas commercial consumer, in case of commercial consumer, the demand is usually less than 100 kilowatt, whereas the domestic consumer is the demand is usually varying between 2 kilowatt to 20 kilowatt. Now, in electrical system, the basic elements are resistor, inductor, and capacitor. We'll discuss one by one in this class. Now, electrical networks. What actually the electrical network is? Electrical network consists of different elements like lamp, fan, tube light. As far as the domestic load is concerned, when we are having a AC supply, and these devices are going to operate on single phase. The single phase supply, we are having a in between fuse. This is for protection. This lamp is operated through a switch S1. Similarly, another fan which is operated through a switch S2, and the third device is operated through a switch S3. Individual devices are controlled by individual switches so that the operation of this device can be managed independently. Now, this lamp is nothing but, when we are going to represent using the basic element, this lamp is nothing but the resistive component, whereas fan is having R, L and C, all these components. Tube lights is also having L and C in circuit, and hence we can say these lamp, fan, tube light, whatever devices, electrical devices we are using at our home, they are the combination of R, L and C. Now, the electrical source and supply. In electrical system, supply is of two types: DC supply and AC supply. Let's consider first DC supply. DC supply is the electrical quantity whose magnitude and direction remains constant with respect to time. Its magnitude is constant. If it is VDC, IDC, VDC and voltage for DC and current for DC. And the different sources of DC are DC generator, battery, fuel cell, etc. Even solar cell also developing DC supply before conversion. Now the AC supply. AC supply, as the name indicates, the quantity whose magnitude and direction varies with respect to time is known as AC. And here it is, let me consider this axis is time and this is magnitude. This magnitude with respect to time at T1 time instant and T2, T3, T4, T5 and so on. Let it is T6. At different time of instant, the magnitude of the quantity is different, and hence in positive cycle the magnitude is varying, whereas when the negative in a negative cycle this magnitude also varies in negative side as well, and hence we can say the AC quantity changes its magnitude as well as direction with respect to time. This is not only the AC supply is having sine wave, it can be a triangular wave, it can be a sawtooth wave, it can be a rectangular wave or square wave. Now, considering the basic element of electrical system or network, the resistor is the first element, is the opposition offered to the flow of current is known as resistance, and it is represented by R or small r. The unit of resistance is ohms. Resistance is given by rho L over A, where rho is the resistivity of the material, L is the length of the material or conductor, A is the cross sectional area of the conductor. Resistance is responsible for the development of heat. In a circuit, when there is circuit which has some resistance, when current is flowing, that resistance always there are I square R loss, and this is nothing but heat. Now, since the effect of resistance can be algebraically summed in order to find the current in the given network, and therefore we can say I is equal to V by R according to Ohm's law. Now, if we are connecting different resistances in series, the total resistance of the circuit will be R1 plus R2 plus R3, and hence we can say with the increase or decrease of the resistance, the resultant value of current also going to be increase or decrease. This since the response versus excitation graph follows a straight line, and hence we can say resistive circuit is nothing but a linear element and has almost the same behavior. Resistance has almost the same behavior with AC and DC supply as well. Now the second element is inductor. It is represented by L. The opposition offered by the inductor to the flow of current is known as inductive reactance, and which is represented by XL. Mathematically, XL can be represented as XL is equal to 2 pi FL, where F is the supply frequency and L is the inductance. And symbolically, inductor is represented just like a solenoid. Now, DC supply. For DC supply, we know the frequency is 0, and hence at DC supply XL will become 0. Therefore, we can say during the steady state operation of DC supply, the inductor behave like a short circuit. Now, for AC supply, there is some finite value of frequency, and hence XL will be having some finite value and it can never be 0. And no opposition to the flow of currents simply means circuit behave like a short circuit, and inductor at DC supply creates short circuit, whereas at AC supply it will be having some finite opposition. The inductance is responsible for the development of magnetic field, since the effect of inductance can be algebraically summed in order to find the response in a given network, and therefore we can say E is equal to L di by dt, and where if there are three inductors are connected in series, the resultant value of inductance is L1 plus L2 plus L3, and hence we can say this the EMF response, that is EMF developed in the circuit with the variation in L in overall inductance of the circuit follows a straight line, and hence we can say inductor is a linear element. Now, the third element is capacitor, which is represented by C. The position offered by the capacitor to the flow of current is known as capacitive reactance, and it is represented by Xc. Here, Xc is equal to 1 by 2 pi Fc, where F is the supply frequency, C is the capacitance. For analyzing DC supply, the supply frequency is 0, and if frequency is 0, this function will become infinity for DC supply under steady state operation. Similarly, the full opposition to the flow of current simply means the circuit behave like an open circuit. It means when the capacitor is connected across DC supply, once the capacitor is fully charged or under steady state operation, it behave like an open circuit and no current will flow through the circuit. The capacitance is responsible for the development of electric field, whereas the inductor was responsible for the development of magnetic field. Since the effect of capacitor can be algebraically summed in order to find the response in a given network, therefore we can say I is equal to C dV by dt. When we are connecting the different capacitor in parallel, the response of this capacitance will be algebraically summed, and hence the total capacitance of the circuit will be C1 plus C2 plus C3, and it follows a varies linearly, and hence we can say the capacitor is also a linear element. Now, considering the network, in an electrical system, network is nothing but a group of components arranged together consisting of active and passive element is known as a network. These are the two figures which shows the AC and DC. With AC and DC supply, two networks having AC supply and DC supply. This is the network which is subjected to AC supply is known as AC network, whereas AC network, whereas the network which is subjected to DC supply is known as DC network. Now, as far as the system is concerned, a network is said to be a system when there is some bounded input, there is some bounded output corresponding to the bounded input, and this can be possible with the application of AC supply as well as the DC supply. Now, the network can be represented in three ways. The and can be arranged in three ways, with individually or in combination. If there are two or more than two elements, basic elements are connected in series, this network is known as series network. Whereas if two or more than two elements are connected in parallel, the network is known as parallel network. However, the series and parallel combination can be represented together, and that particular network is known as series parallel network. Here three elements are connected in series, and the total resistance of the circuit is R1 plus, R2 plus, R3. And in this case, all the current flowing in these three elements is same. Whereas in this case, these three elements are connected in parallel. Why? Because this voltage applied across this the voltage applied across these three elements is same, that is V. Voltage across R2 is V VDC, voltage across R3 is VDC, and hence we can say the the three elements are connected in parallel. However, in the third case, the voltage across this resistance R1, it depends on the current flowing in R1, that is I1 R1, the voltage will drop will become, where the voltage across R3, it depends upon current I2, and in this circuit it depends upon I3. The voltage drop across these two elements is the sum of this resultant voltage. However, the voltage drop of these two elements when added in this component, which will be equals to VDC, and hence this type of network is known as series parallel network.